So today we're going to talk about the action potentials that a cardiac muscle cell has. Now, if you recall from your readings or from other videos that you've watched, the action potential looks much different than a pacemaker cell or even skeletal muscle. And so we're just going to start off here. So remember that a cardiac pacemaker cell does have a resting potential, so that's rest, followed by a very steep depolarization. From there we have this little repolarization that's called early repolarization, and then we have what we call the plateau phase, where membrane potential is remaining constant, and then we have repolarization before we get to back to resting potential. So just to label these, so we've got rest, we've got depolarization, which is caused by sodium influx. Okay, up here we've got early repolarization. I'm just going to abbreviate here. Okay, remember, repolarization is always potassium efflux. So just to be clear, we're talking there. Then we've got the plateau, which is this part here, is caused by two things. We have calcium going in, okay, but that is counteracted or offset by potassium going out. And then finally, over here, we've got repolarization, which again is caused by potassium leaving the cell. Okay, so potassium efflux. Okay, so when we talk about cardiac muscle cell action potentials, the duration is very long. Okay, and this is really important because it allows for the ventricles to fill up with blood. It allows the heart a chance to relax. It prevents tetanus, and ultimately what it's doing is it's allowing the heart to be more efficient. All right. Just like with the pacemaker cell, though, I want to talk about what happens when we have sympathetic response or a parasympathetic response. So with green, we're going to do sympathetic response, okay? And so what this does is this actually increases calcium permeability, okay? And it does this during the plateau. Okay, so I want you to think for a moment, well, what will happen to the plateau if we let more calcium go in? And the answer is that instead of having this long plateau, we're actually going to have this little bump in depolarization. What also happens at the same time is that this turns on the turbo for the calcium ATPase pump. Okay? And so what happens is we let more calcium into the cell, but almost immediately that calcium is pumped back into the sarcoplasmic reticulum, so we have this sharp peak, and then we're immediately pulling calcium out. And so notice the action potential looks much different. And so the duration of the action potential is actually shorter, right? Whereas with the original action potential, we go all the way here. So our duration is much longer, okay? When we have a sympathetic response, I think it looks like an owl or Batman or something like that. The action potential does. Okay, and so ultimately what this does is the increase in calcium leads to more cross bridges. And as you've heard me say 1,000 times, if I have more cross bridges, I have more force. And so as a result, I'll have an increased stroke volume. Okay, and so this is important, or the sympathetic nervous system allows my heart to pump more forcefully, which will allow more blood to exit my heart. Now, on the flip side, we've got the parasympathetic nervous system. So I'm going to write that over here. So we've got the parasympathetic nervous system. And what does this do? The answer is nothing. Essentially nothing. Okay? There's really no effect of the parasympathetic nervous system on stroke volume. Okay? Or at least no measurable or no significant effect. And so when it comes to altering stroke volume, it's either we have a sympathetic response and increases stroke volume, or we don't have a sympathetic response and nothing really changes, okay? And so just to recap, when we have a sympathetic response, we only change the plateau. The plateau becomes shorter in duration because we're letting more calcium in, but at the same time we're increasing the activity of the calcium ATPase pump through the activation of an enzyme called phospholamban. And so as a result, we get a much different looking action potential, and this allows the refractory period to be shorter so that we can have more frequent contractions that are stronger. And if you think about exercise, this is important. When I go out to exercise, so when I run later today, my heart rate's going to increase. I want to deliver more oxygen, so in order to do that, I need to pump more blood. And so this allows me to do that. We can have more frequent action potentials. We shorten that refractory period, which allows this to happen, and so my stroke volume increases. Pacemaker cells deal with heart rate, muscle cells deal with stroke volume.